Welcome back to video 5 on solving trigonometric equations. We're now going to look at secant theta tangent theta minus cosine theta cotangent theta equals sine theta. The recommendation here is to multiply by sine, and so I'll go ahead and multiply both sides of this equation by sine theta. Next, I'll distribute sine theta, and I'm going to simplify this stuff inside as well. So I know that secant is 1 over cosine theta. Tangent is sine theta over cosine theta. And cotangent theta is cosine theta over sine theta. And then we just have this cosine theta here multiplied to it. Now, when I multiply this by sine theta on the outside, I can start seeing some patterns that might help me reduce. I have a sine squared theta now in the numerator over cosine squared theta minus cosine squared theta, because when I multiply the sine theta in, the sine theta will divide with the one in the denominator. On the right side of my equation, I have sine squared theta. This gives me tangent squared theta minus cosine squared theta equals sine squared theta. And now I can add cosine squared theta to both sides. And I get tangent squared theta is equal to sine squared theta plus cosine squared theta. And at this point, you should recognize that the sine squared theta plus cosine squared theta is another Pythagorean identity equal to 1. That gives me tangent squared theta is equal to 1, and I can take the square root of both sides. Whenever I impose an even root on both sides of an equation, I have to give it a plus or minus sign on that, and so I'll have tangent of theta is equal to plus or minus 1. If I think of the tangent function, I know that it repeats every period of pi. Between the first interval is centered about the origin between negative pi over 2 and pi over 2. The function is on the bottom left until 0, and then it curves back up and hugs the asymptote to positive infinity as it approaches pi over 2 from the left. And then this pattern just repeats over and over and over again. The question is, where does the tangent curve hit 1 and negative 1? And so that's where we have to think about this repetition of the tangent function. I happen to know that plus or minus pi over 4 will give me a plus or minus 1. That means that I need to think about the tan inverse of plus or minus 1, and that will give me my 2 solutions for the first period, but then it just repeats. This means that theta, my angle that I'm trying to find, is equal to pi over 4, that's this one up here, pi over 4, plus pi k, meaning it happens every period of the tangent. I also will have this other value for the angle at negative pi over 4. And that is going to be theta is equal to negative pi over 4 plus pi k. If for any reason your homework or your textbook says do not give a negative angle, then go ahead and add pi to this. That would give you an equivalent solution where you have pi over 4 negative plus pi, where that would be 4 pi over 4, and that would give you 3 pi over 4 plus pi k. Notice that this solution here for the angle is equivalent to the one above without a negative initial angle. But if you're thinking about this in terms of your actual function for tangent, this can be totally acceptable.